Hi all, thanks for joining today and hope you had a great weekend. So today we'll start with the core concepts. For example, there is a Linux. What is the difference between Linux and Windows? What do you feel the difference between the Linux and Windows? So basically the Linux is a kind of open source and Windows is a kind of, we can say it was controlled by a Microsoft. And when there are multiple Linux distributions, for example, we have Ubuntu, we have uh, CentOS, we have Fedora. So this all comes under Unix platform. And when coming to the open source versus Ashwati, so so that's the basic difference between the Linux and the Windows was the open source versus the commercial. So open source is something that the code you can take that code and you can modify according to your requirements. And for example, you have some set of commands in the Unix and you can modify according to your requirements and you can proceed. For example, in the Windows, you cannot do as you want. You cannot modify the, OS, the core operating system. And for example, if you got any issues in the Windows, you need to reach out to Microsoft. But in the Linux, it's not like that. You can fix it by yourself. And coming to security, so there is a lot of difference between the open source and the security. For example, Linux and the Windows. For example, if you see any hacker can easily target the audience which are uh, who are vulnerable to the large audience instead of, for example, I can tell you in this way. So you see the terrorists will target only the places which are crowded areas, right? So in the same way, so most of the users, home users will use the Windows, and what will happen? The terrorists, the hackers easily target the people who are larger audience, larger use, and and also in the Windows you can easily install and easily you can push the up, say a small APK file and you can install it and then gone, it's the virus get injected. So in the Linux it's not like that. So in the Linux it's a kind of you need to install and you need to create a file in the form of script. And once you create a file once you create a file and then you need to give the apply the permissions for that. And once you apply the permissions and then you have to install that, and once you install it will check the dependencies. So these all things will be there in the Linux. So that's the reason you cannot easily install a file in the install an application in the Linux. And if you install also, it's more secure. For example, you take uh, all the phones androids are kind of we have an inside the OS is Linux, and those are more secure. I can see. Yeah. So yeah. So hi Shruti, hi Raja, hi Sagar. Thanks for joining. Hope you had a great weekend. Huh?
Yes, sir.
So here I'm discussing about the open source versus commercial, that is Linux between Windows. That's what I'm discussing about. And so let me share my screen. I think on Friday we had discussed about what containerization, Docker, virtual machines, containerizations, and bare metal services, right? So I'll just share my screen quickly. Right. Hope you're able to see my screen. So instead of going directly to the class, so I just want to interact with the people. So I see people has joined Raja, uh, Puli Reddy, Sagar, and Shruti. Right. So guys, how is your weekend? Before going into the class, I just want to interact with the people. And yeah, so how did you? I hope you had joined on the Friday's class. Who has not joined the Friday's class? So, Rajashekhar, have you joined the class on the Friday, or this is your first class? Hello, I think he has left the chat. I think Puli Reddy, have you joined the class on Friday? Okay, I think it's today Monday, right? Everyone was a bit drowsy, I think. So, Shruti, you have joined right on the Friday's class.
Yes, sir. I have joined.
Great. Okay. So you people got right. So how the what is the difference between the containerization, bare metal, and the virtual machines? These are very essential and these are very important. Why I'm telling you, see, for example, if once you go into the cloud, once you do the DevOps, once you into the DevOps, so they will speak about EC2s, they will speak about VM scale sets. EC2s are in the AWS, and for example, EC2s are AWS, and they will call VM scale sets in Azure, right? So these are nothing but virtual machines. Okay. So the main thing was we will use in the cloud based on the requirement. We have to work on EC2s, virtual machines and containerizations. Containerizations are nothing but, Docker. So we'll call it as a containerizations are Docker, Kubernetes. These are called containerizations. And there is a bare metal service in the AWS and in the Azure. We have bare metal service as well. So for example, if you want any of the company needs uh, for example, if any of the company wants to secure, they doesn't want to share their data across multiple servers, they will take the service as a bare metal. There is a service in the AWS or Azure called bare metal as a service. So they will opt for bare metal as a service. What they will get is they will get one dedicated physical server, and they will be using they will be using that physical server for their applications installations and all. So they doesn't want to maintain, but they will opt the service as an bare metal as a service in the AWS or Azure. Hope you are clear. So what is a, hope you are clear with the difference between what is VMs and what are bare metal as a service, what are containerizations, right? And as I told, I think I'll touch base on again what is the difference between Linux and Windows. What is the open source? Why people are so fond of open sources, and why people are uh, bit, I don't say bit hesitant. There are so many legacy applications, for example, .NET applications, which work on Windows. So I'll tell you why. What is the difference between open source versus commercial, and what are the applications we have open source and why we are using it and why there is a lot of, I mean, Slack overview, you can say, or communities in the open source, why there are so many. So I can tell you that. So first, when we say open source, the first thing it strikes into our mind in the DevOps technologies is Linux, the OS operating system. So source code is freely available. For example, source code in the sense in the Linux we have a kernel, right? That is a heart of the OS, and easily we can modify it if you are very good at Linux development or uh, C development, we can say C, C++, kernel development, we call it as. So easily you can modify and easily you can customize your code, your operating system all together. You can and you can publish it. For example, you take the Red Hat Linux. So that's how they had modified according to the company. They have taken the Unix. Unix is the mother, we can say. Unix is the OS. So from the Unix, Red Hat Linux, Ubuntu, Fedora, and what are the CentOS. So these all got derived, right, from the Unix itself. So that's what the open source. For example, if you in your company, if you want to customize, there are Linux commands. If you want to customize them, you can name it your. I mean, you can keep your name and you can enter the command. It will work. So that's what the beauty is. And commercial. One second. Sorry, one second. Yeah. Coming to the commercial, like I mean, if you take the Windows, source code is owned by Microsoft, right? And it is not shared with the public. And you cannot modify. For example, if you get any issues on the Microsoft OS, you need to contact the Microsoft people. You cannot go and you cannot do whatever you want, right? And those are licenses, paid license. You have to pay the license for every, I mean, for every year or monthly based. And as I told, customizable and also the support. So when it comes to support and updates, there are like for commercial you will get 24 by 7 because you are paying you for the service. And for the support type, coming to the open source, you cannot get the 24 by 7 because no one supports that. I mean, no one is ready to support you uh, because it's a free version. And also there will be no one to guide you to use this, to use that, and you modify accordingly. So that is the reason people will go with the Red Hat or people will go with the Ubuntu commercial license because they will get the support from the Red Hat line. From the Red Hat, most of the industry they use the Red Hat or Amazon Linux. So they get the support from the Red Hat and immediately they can resolve the issues. But it will be a minimal cost. And also coming to the security, as I told, so security is something, it's a open source security, or I mean, coming to OS operating system. So that is a top notch in the security, I can say, in the operating system for a Linux, I can say. And for the Windows, as I told, it's very vulnerable. It was so vulnerable because, and also I'll tell you one thing. So why people choose Linux rather than Windows? For example, you keep your Windows system like this, I mean, open for a couple of months, and you go back to your desktop, or you go back to your laptop, and if you move the cursor like this, and it will move. If you move the cursor like right ways, and it will move left ways, and it will get stuck. It will behave very weirdly, right? So in the same way, if you go to the Linux and if you enter the command ls-ltr, the beauty is it will immediately, it will not stuck. That's the reason people will choose Linux. For example, for 1,000 days, if you want to more than 2 years, 3 years, 5 years, if you want to sustain, if you want your system applications to run without hindrance, so that is where we use Linux, right? So that is where we can people choose your applications for the resiliency, for the uptime. So for these things, people will use Linux rather than Windows. Hope you are clear with these things, right? Now, yeah. So any doubts, Shruti, or so why people choose Linux rather than Windows, and why people go to the most of the people you might think why so many people use Linux rather than, so that's the main cause. And yesterday we discussed about OS Linux, and these are some of the topics which we are going to cover in the course. So we spoke about deployment orchestration, for example, Argo CD and Jenkins, and we we are at the configuration management, right? So we had configuration management, and we had orchestration management, right? Orchestration tool. So I'll tell you, I think we are at this point, we are discussing about the configuration management and orchestration tool. And yeah. Okay. So coming to the configuration management tool, we use Ansible, as I told. So we had some of the tools called Puppet, and we have Ansible, we have Puppet, and we have Chef. So Ansible works on pull-based mechanism, and I'll tell you what is pull-based mechanism. And we have Chef and Puppet. So Ansible is something agentless, right? Chef and Puppet are agent. They are they require an agent to be installed on the servers. And configuration management is something agentless. So Ansible is something agentless. For example, in the Linux, we configure the server. For example, if you want one server to communicate with the another server, right? So what do you do? Any idea, Shruti? So, for example, if you want to communicate one server with the another server, so what do you do? How do you establish the connection? Any idea? Have you ever thought that how they connect each other?
Like if one server wants to have an info of the other server, like you'll have etc host file. In that etc host, you will give the name of the server, I think.
Okay, so etc hosts we use for the host name. For example, your name is Shruti. So you want to, for example, I am from the outsider. I want to convey that, okay, Shruti is the one. So it's a kind of naming convention what we do in the etc host name. It's a kind of DNS, domain name resolution. So those things we are going to do in the etc host name. So have you heard about SSH keys, SSH
Right.
host,
Yes, yes.
right? So for
Yeah.
example, if we copy the public key, we generate them using SSH keygen, and we get the public and private key. And then we are going to copy that public key from that server to another server in the authorizations file. And that's how we establish the connection between those two, right? So that is the main core component in the Ansible, how it works in the backend. So it completely works on SSH based, SSH key based, right? Once we establish the connection between the two servers or using SSH keygen, and that's how we can run the ad hoc commands, playbooks, and so we can do all the stuff based on these SSH keychains. That is the core component. Why? I mean, in the Ansible, in the backend, if anyone asks in the interview or if anyone asks how Ansible works inside the Linux, so you can answer based on the SSH keychain, right? And coming to the Terraform. So as I told, we have Chef and Puppet. So Chef and Puppet, we're not going to discuss this, but so these are also configuration management tools. Hope you are clear with the what are configuration management tools are. Configuration management tools are nothing but managing your environment. For example, as I told yesterday also, I'll just reiterate it. So if you want to run a command, or if you want to apply the patching, or if you want to do some administration tasks, right? So if you want to do those tasks, so you will be using this configuration management tool. Okay. And so orchestration, now coming to the infrastructure as a code. So, so do you want me to explain some more things about this configuration management tool, Shruti? So I'll just, so hope you have understood this. What is configuration management tool?
Ah, yes, sir. Understood.
Yeah. So now we'll speak about, now we'll talk about infrastructure as a code. We'll call it as an IAC. And we have in the infrastructure as a code, we have Terraform. We have, which is a famous, I mean, we can say most of the famous is nothing but most of the where most of the companies use, we call it as a famous because we have to concentrate on that. See, for example, there are 100 job applications and 60%, I mean, almost 100% will ask infrastructure as a code. In that 100%, like infrastructure as a code, 80% will look out for Terraform and 20% will look out for any of the cloud formation or Azure template, Azure RM, Azure resource manager. We call it as an ARM templates, AWS cloud formation, AWS cloud formation, or ARM templates. ARM templates, right? And so these are used for provisioning the infrastructure. So you understand. So these are mainly used for provisioning the infrastructure. So what do you mean by infrastructure? So infrastructure is nothing but, for example, you had a cluster. You have a environment for in our previous. I mean, if you want to install an server or if you want to install an application onto the server, so what do? You have some of steps you follow. For example, you need to install the OS, you need to attach the hard disks, you need to install the Ethernet, you need to do the hardening, you need to after doing the hardening is nothing but you need to install the OS patch. I mean, for example, to bring into your environment, you install some security related packages. So that's what we call it as a hardening. And when you install an application, you do some configurations, right? For example, you enable the RBAC, RBAC in the role based access control, and you enable some of the security features you can say, right? And so some related to configurations. So you do those all configurations and you enable the access and you configure the security, you configure the networking. So these all things you are going to work on. So that is what with all those things can be provisioned with a one click. That is what infrastructure as a code. You got it. So you can, in a simple term, what is a uh, difference between infrastructure as a code and configuration management? I think yeah, as I told yesterday also, so I'll just reiterate. So infrastructure as a code, for example, I'll give you simple example. Think of building a house and one second. You think of building a house and sorry, I got a call. So you think of building a house versus after building the house, you arranging the furniture. So arranging the furniture is nothing but configuration as a management, configuration management, and infrastructure as a code is something you build a house. For example, you want to build a house and you want to build multiple houses, like for example, gated community. And now you people are seeing, right? So previously we have hollow bricks. I mean, hollow bricks in the sense the people used to take to construct an apartment or a building. I mean, for a 30 stores or 20 store building. So they used to take a lot of time. But now there is a technology called My One technology. Have you heard about this My One technology? They will just construct with a kind of concrete and they are going to build the complete floors within, I mean, they will have the base and they will keep the frames and they will pour the concrete and they will construct it. They will construct too fast. Like within 1 year, maximum one and a half year, they will construct the complete 30, 40 floors or 50 floors. So they will construct. So that's what the infrastructure as a code. So if you want to build multiple application, I mean multiple servers inside inside it, you want it as a pack. Uh, that is where this infrastructure as a code is kind of will be helpful. And configuration management after after configuring the application. So if you want to manage those applications, so then you need the configuration management, right? So to provision the infrastructure, we can say the infrastructure as a code. And so hope you understand that building, think as a building a new house and arranging the infrastructure. I mean, arranging the house inside the after building. So that's what configuration management is. One second. Yeah. So it's done configuration management. So in the configuration management Terraform, so it was managed by HashiCorp. And so it can, why Terraform was so popular was it can integrate with the AWS and Azure. It's a multi-cloud. So where if you want on-premise or if you want integrate with the AWS, if you want to integrate with ARM, I mean Azure, GCP, multi-cloud. So you can integrate with the anything. But AWS is something cloud formation. Obviously, you can use in AWS, and Azure you can use in Azure templates. So that's the reason Terraform is most popular, and we have Pulumi as well. So which is recently evolved, I think so. So I mean Pulumi. And now coming to the API gateway. So service mesh or API gateway, we can say. Have you heard about this service mesh or API gateway? So this is something which we are going to discuss, which is very important to understand the DevOps technologies and SRS technologies. And most people will skip this part because it is people might neglect this service mesh or API gateway because and I don't know why outside everyone will neglect. If this is the core part, if you want to understand how an application works or how application is getting routed to the external people, and uh, and how observability works by using these service mesh or API gateway, these are these concepts are very important to understand an application. And also in the interview perspective, if you speak about these terminology, service mesh and API gateway, how you configured in the real time. So done, you will be, and most of the troubleshooting questions also inside the, for example, any troubleshooting will reside with the this API gateway and or the I mean API gateway. For example, internal, external API gateway, internal API gateway, and there are so many things, right? So NGNX, and we have we'll speak about NGNX, and we'll speak about STO and AWS API gateway and Azure API gateway. AWS or Azure API gateway. So it is very important because I mean I don't know why people will neglect, as I told, they neglect, most of the people will it's a kind of hanging fruit, I can say. So this is very, very important to understand how an application works in the real time. And for example, without this, an application will work, can work. I mean, these are all, you can say these are all kind of automation tools in the sense, these are kind of, if these are not there, it can sustain. But without these, an application cannot sustain. Gateway. So in order to access the outside routing, all these things, right? And now coming to the AWS cloud platform, we'll discuss about AWS, and we are going to discuss on the AWS services like EC2, S3. So what are the services are going to cover in all the MLOps, DevOps, and DevOps pipelines. And so these are all things we are going to discuss in AWS and Azure as well. So we are going to discuss what is the difference between AWS services and Azure services and how they configure in AWS and how they get configured in Azure. So these are all things we are going to discuss in the class, right? And I want to tell you here one more thing. In the Jenkins, we have, there are two pipelines. I think most of the people knows, right? So it's a kind of uh, so we have Jenkins pipelines called declarative and scripted pipelines. So why I'm saying this now is, so as I'm going between the differences, so I just want to cover this. What is a, I mean, declarative pipeline and scripted pipeline. So declarative pipeline is nothing but, uh, it's the latest kind of tool, latest kind of programming language, I can say, like, and so latest kind of, I mean, so in this way I can tell you. So the basic difference, I mean, between the declarative and the scripted pipeline was, declarative pipeline we can write easily. So for example, it starts with the pipeline. So, and the scripted pipeline is something which are legacy, and the prog we have to write with the program. So it's a bit complex, right? So we are going to discuss this as well. Declarative pipelines, how do we write declarative pipelines, and how do we deploy using declarative pipelines. And scripted pipelines is something, as I told, these are written by Groovy. Everything was written by Groovy, and so scripted is something, it's a kind of Jenkins scripted language, and these are legacy language, and we are not using the scripted pipelines, and we are using declarative pipelines. And so it's a kind of, declarative is something kind of, as I told, it's a YAML, and I highly recommend using. I'll touch base on YAML as well. I'll touch base on YAML basics, because why I'm telling I'll touch base on YAML is, if you want to write any playbook, you should write in YAML, and you should understand what is the YAML base. I mean, what is an YAML, and So why was it used? And so these all things, what are the terminology used in AML? So what is the syntax? So these all things, if you understand the basics of the AML, it will be easier for you to get into the course. So yeah, it will be easier for you to get into the course, and it will be easier some YAML based scripts or YAML based, I mean YAML based pipelines. Or so as I told, so see, if you see Jenkins, it's written by the scripted pipelines are written by Groovy, and the declarative pipelines are written by YAML, right? So we are going to discuss the YAML basics as well. So why I'm writing these things are to not miss the concepts, and also I'll be touch basing on everything. So apart from, for example, if you see in the course content, there are some things which are missing. So, but in this, it will not be missed. It will be kind of added apart from the uh, apart from the course content what we have, right? So that's what I just want to tell you. What is it? I mean, the declarative pipelines versus the scripted pipelines, right? And yeah, we have this uh, simple example I want to give on the declarative versus scripted pipelines. For example, if you want to, declarative is something kind of structured recipe. So they are easy to read, or they are easy to prone mistakes, not to prone mistakes. I mean, easily you can detect by seeing that you can understand the declarative pipe. With the declarative pipelines, easily you can understand the code. Easily you can understand the what are the stages for the next pipeline. So easily you can do this with this. Coming to scripted pipeline, so these are flexible, but these are complex. You cannot understand. I mean, you cannot understand in the sense you can. It's not that easier compared to the declarative pipeline, and you have to create your own logic. So these all things are in the declarative pipeline. Now coming to the AWS cloud. So as I told, we are going to discuss with the AWS in the AWS DevOps pipeline services, DevOps pipeline services, and we are going to discuss on infra services, and platform as a service. So platform as a service is nothing but EKS. I'll tell you, EKS is a kind of platform as a service. Why? What is a infrastructure as a service? What is a platform as a service? I'm going to discuss on the since I need to I mean I need to reiterate this on the class as well. So I'll just tell you what is the difference between infrastructure as a service, platform as a service, and software as a service. So, so the basic infrastructure as a service is nothing but I'll discuss this software as a service. Yeah. So, for example, so infrastructure as a service is nothing but you provide virtual servers, easy to instances, networking, storage, hard disks. So these all comes under infrastructure as a service. For example, you take the load balancer, security groups, and VPCs, and what do we call networking. So this all comes under infrastructure as a service, and platform as a service is nothing but it it will give you for the kind of development and kind of deployment platforms. For example, if you want to build and deploy applications easily using these services, for one of the example is EKS. So it's a kind of semi-managed, we can say semi-managed in the sense they will create an platform and you can use that platform. They can and coming to infrastructure as a service is nothing but you need to build it from the scratch. So take an, for example, mm, okay. So infrastructure as a service is nothing but you need to build a house which is from the scratch, right? So platform as a service is nothing but you, for example, they will give you the function hall and you need to arrange your own, you need to manage your own, they will give you the platform and you need to do yourself. For example, you need to call your relatives, you need to arrange your meals, lunch buffet or whatever. So that is what the platform as a service. And SaaS as a service is nothing but software as a service. They are ready to use. So if you want to go for a rental, there is a house which is fully furnished house and you want to go for a rental, so you know you can take this software as a service. So it's a kind of ready to use applications. For example, you take there is an application called SAP. Okay, so for example, you take the database MySQL or Aurora, so they'll give you the software as a service and you can use that, right? So hope you understand between what are the application as a service and the platform as a service. I mean, platform as a service, infrastructure as IaaS, and software as a service. So these are the main differences between these. I mean, these are the main differences. And yeah, so what it provides in the infrastructure as a service is, as I told, virtual machines, and you manage your OS. And platform as a service is nothing but the runtime environment they will provide, and software as a service is something kind of fully functional software they will provide. So some of the examples are EC2, IaaS as a service, EC2 we can give, or VMs scale sets, Azure VM scale sets, or VPN, we can VPC. Okay. So platform as a service is nothing but, as I told, EKS, Elastic Beanstalk, we can Elastic Beanstalk, right? And Azure App Service, something, right? Software as a service is something that you can take Office 365. So which is a beautiful example, right? Office 365, which comes with a bundle, and Gmail service. So these all things are kind of software as a service, right? So hope you understand what is the difference between, I mean, what are the AWS, I mean, what are the things we are going to discuss in the AWS and Azure. And we are going to discuss on MLOps as well, MLOps services. I'll tell you what are the MLOps services we are going to use. So MLOps services, I'll tell you when it comes to the MLOps. We are going to discuss after containerization we have, and monitoring, and SRE, and then we'll speak about the envelopes. And coming to containerization, so as I told, so coming to containerization, we are using, we will use the Docker. We have Podman as well, but we use Docker because most of the people will use, uh, in the industry they will use Docker. So we'll use Dockers for building, writing the images, deploying it, writing, deploying, maintaining all these things. We will maintaining. So we will use all these things for Docker. We will use containers, and for container orchestration, orchestration. So we'll use for container orchestration, we use Kubernetes. So we will see how we can provision. I mean, how we can, yeah, provision EKS or AKS, and we will be deploying some applications and we will manage them. So these all things we are going to do into the Kubernetes. So you can ask me what is the difference between, I mean, Kubernetes and the Docker. So have you heard about what is, I mean, what is the difference between container and container orchestration? So container is nothing but it's a standalone, we can say, and container orchestration is something but cluster. So in the simple words, I just told you in the simple words. So so the basic difference was containers are nothing but they are lightweight and they are portable and to run applications across the environments. For example, consistently on the each and every application. So use the containers. So for example, you want to scale it. For example, you have 100 applications, you want to scale it for 200 instances. Okay, not scaling the applications, scaling the horizontally, like scaling the applications in order they doesn't go to the downtime. So that's where we use the Kubernetes. So it's a kind of, for example, you have Docker, you have you will be having one image, uh, one image, two images, or some of the pods, we can say, some of the containers. So if you have multiple containers, if you have hundreds of pods, if you have hundreds of images, that's where the Kubernetes comes into the picture. So we in the Docker we have the Docker Swarm as well. Docker Swarm is nothing but I think it got extended now, but Docker Swarm is a kind of the same as Kubernetes. So I'll tell you with a simple example to correlate with. For example, you take the lunchbox. So it is a kind of neatly packed meal. So where you can eat it. So you can take that lunchbox and you can have it. You can have it anywhere. After going to the office, you can have it. For example, so in a restaurant, so there are hundreds of lunch boxes, right? So you need to organize those hundreds of lunch boxes and decides what to cook, what to deliver. So these comes under container orchestration. So a single lunch box is it's simple, you will deliver it. But when a restaurant and the kitchen manager, he will organize all those lunch boxes and he will decide where to cook, who to cook, what to cook. So that's where the container orchestration comes into the picture. So hope you are clear. So so the libraries, dependencies, the configuration files, everything will be included into a package. That's what the container does. And container orchestrations is something that it mainly focuses on the outer part, like how to restart if one fails. For example, how to scale from 3 to 300 containers, and how to balance the traffic between those the containers, one container to another container, and so that's what the difference between the container and the container orchestration is. Hope you are clear with this. Yeah, Shruti. So hope you are clear with this. Any doubts on?
No, sir, clear.
Yeah. Okay. So now we have discussed on, and we'll touch base on Helm. So what is a Helm? Helm chart is nothing but it's a kind of package repository. For example, if you want to install in the OS, in the operating system, if you want to install any application, you use M repository, right? M or app repository on in the Linux. For example, if you take the desktop, so you will install the .apt package. So they call it as a package manager. So in the same way, Helm is nothing but package manager. If you want to install an application onto the Kubernetes, so that is where the Helm is. It's a kind of package manager. So we'll discuss about how we'll install the applications, how we are going to manage those applications onto the Kubernetes. So these all things we are going to discuss on the Helm. And we are going to discuss on the service discovery network, which is very important. This is also outside, I don't think so people will discuss much on this service discovery and the networking. but we are going to touch base on these as well. Like for example, how the networking takes place in the Kubernetes, and we are going to discuss on the kube DNS and core DNS and Calico Calico networking. So this is very Calico is important because most of the people will use outside the Calico networking. And next comes is ingress controllers. So as I told, the API gateway, right? So this is where ingress controllers also comes under this API gateway. So I'll take this and I'll just paste it. Ingress controllers. Ingress controllers. I can say this ALB as I told. So this Azure application load balancer, application load balancer, all these AWS ALB, Azure ALB. So these all things we are going to discuss in the service API gateway. And yeah, and obviously we are going to see the cluster management tools. For example, cluster management tools consist of kubectl, and so that is how we are going to control the Kubernetes cluster, and we are going to do with Lens as well. So Lens is something, these are all the tools to manage the Kubernetes cluster. Tools in the sense, nothing but, for example, you are running the uh, ls-ltr in the Linux command tool. So that's what you're doing it. You are controlling the Linux server. So that is what the kubectl commands are. Kubectl are nothing but you want to do any operations on the Kubernetes cluster, you use the kubectl command. So yeah, that's all from today. So tomorrow we'll discuss about monitoring and SRE topics and MLOps. Like going forward, we are going to discuss those things. So yeah, any doubts on this? So I'll be teaching in this way. For example, I'm going to tell you, I'm going to give you the after every class, I'm going to give you the notepad. What I'm doing is whatever I'll do, I'll just give you the notepad. And for example, if there are any configurations, I'll create the document and before itself the step by step, and you can follow that document and you can create your on by your own. So that's how I'll follow in my lectures. I'll not go through the PPT because I PPT is something rigid I doesn't like. So where in the notepad we can modify or we can do whatever we want, I feel. So we can add more topics as well in the notepad. So yeah, if you have any concerns, you can raise it with me and you can raise it with us. So yeah, that's it. Any doubts or anything? Yeah, Shruti or Vema, anyone, any doubts regarding these topics? Or if you have any doubts in your, when you see, for example, the problem with the DevOps technologies are when you go outside, people will speak about the fancy technologies. They will speak about, if you say that you doesn't know, they will make you hell out of. They will show more kind of, yeah. Have you worked on this technology? Have you worked on Terraform? There is a thing called HSR. There is a thing called this kind of MLOps model. Have you worked on this MLOps? So they will come up with the multiple things. So you people don't fear for any of the thing, any of the terminology what they use or any technology what they use, because I'm telling you now, once you go into the office, once you step into the any of the company, what you learned is different, and uh, what you get onto the hands-on experience, I mean what you get onto the project is different. I'll be 100% sure. So what you focus on the technologies and what I mean, you focus on the concepts. For example, there is a CI/CD pipeline. So how it works, what it does, and Linux. How do you log in? How do you run the command? What it does in the backend? So that's what you understand. For example, in the Kubernetes, how you log into the Kubernetes, what are the process you are going to do. And you know one thing, in Kubernetes, there is nothing. People will say there is a Kubernetes is so big, it's a very vast, it's nothing. There are hardly 10 commands we have in the Kubernetes, I'll tell you. And there are troubleshooting, there are very limited troubleshooting commands in the Kubernetes. It hardly takes, for example, Kubernetes, there is a log, uh, describe pods, describe log, logs -f, describe pods. That's it. You go into the check in the events and you're going to get the liveness and readiness. So that is what the difference between, those are very easier. Those are pretty easy. And what you need to do is you just concentrate on the concepts rather than the, technology or terminology, what people speak from the outside. And you can feel the difference after these classes. You can feel the difference, and you can estimate yourself how you can draw your graph before the class and after the class, what you learn, right? Yeah. So yeah, that's it for today. And if you have any doubts, just reach out to me. And once I complete this, I'll just share it with you, the notepad, and you can go through this. Yeah. Thank you. Thank you guys. Thank you all.
Thank you, sir.
Thank you.